continue our lesson with stuffed with pizza. And in our last lesson, we talked about how we add fractions without common denominators. And then we solved the story problem, trying to find out which boy ate more pizza. And today we're going to do a quick little review again on adding fractions with uncommon denominators. And then I have a real-world problem-solving problem for you that you're going to work with, and we're actually going to use them on Friday. We're going to use your answers, what you came up with, your data, for an activity on Friday, because Friday is Pi Day. Remember, I told you I kept it a secret. I said, what's special about Friday? Friday it's a world celebrated day, and it's pi, not P-I-E, but pi is in the math symbol P-I. So we're going to be doing some work with that on Friday with what we are going to be gathering data from today. Okay? So please gather your math notes and come to the carpet. And make sure we leave a little space to get around the table there, Jordan, so we can come to the board. All right, in our last lesson, we looked at how to add fractions that have common denominators. And we had multiple strategies being shared. We had some students did a fraction circle. Some used fraction sticks. Some used ratios and as parts of a whole group. And then we also worked with, now that we know how to add fractions with like denominators, how do we add fractions with uncommon denominators? And we spent a lot of time on that last time because we still didn't have a real strong foundation for that concept. So we're going to do, hopefully, a quick review today, going back to that same idea of adding fractions with uncommon denominators. And I'd like you to use a strategy that models your thinking. So go ahead and solve this problem in your math notes. What is 1/2 plus 2/3? And choose a strategy that's going to model your thinking on how you solved it. I'll give you just about a minute more. right, Allie, will you come up and share your strategy with us?
What I did is I took 2 squares and I put one as 2/3 and one as 1/2. And I took the 2/3 and I split it into 2 sections so that then you could have equal denominators. And I took the 3 and I made this into 3 sections. Then it equals to 6 as the whole for both of them. And this one represents 4/6, and this one represents 3/6. If you add 4 plus 3 equals 7, and then your denominator stays the same. And then you go 7 divided by 6, 1. Bring your 6 down, that equals 1, and then that becomes 1/6.
So what is
your answer would be 1/6.
Any questions or comments? Brian?
I would like to disagree with your strategy because Mrs. Paxton said adding them with unlike denominators, not with common denominators.
Okay, so who'd like to comment with what Brian just said? Jacob?
I like to disagree to what Brian said because uncommon denominators, you can make them common by multiplying the number of sections by the number of the other fractions denominator. For example, like she did up there, 2/3 and 1/2. The denominators are 3 and 2. The 2/3 was split in 2 because the denominator is 2 and 1/2, and the other way around.
Anything else? Anyone else want to comment? Drake?
I would also like to disagree with Brian because with her strategy, she actually did start out with like Jacob said, she did start out with uncommon denominators, but she ended up doing the, what Jacob said with the 1/2 and 2/3, and she got a common denominator out of it.
So, Brian, help me understand your thinking. Because I said uncommon denominators, you tried to solve it keeping the denominators uncommon.
Yeah.
Okay, so remembering what we talked about last week, can anyone help Brian with that? He tried to add his fractions keeping them uncommon. Allie?
Last week, Cinder said that we have to have the same denominator so that it was easier to tell the difference and it's easier to add them together.
And so why do we need to have common denominators when we add or subtract fractions?
So it's equal.
What's equal?
The whole
Vanessa?
denominator.
Right, but why do we need to have that? Remember, we spent all that time, I took the piece of paper, pretended it was a chocolate bar and passed it out, and everyone wanted Jacob's chocolate bar. They wanted Jacob's piece. Why? Aiden?
Because his was bigger.
His was bigger, right? Because I didn't cut it into, they weren't all the same size. So when we are adding fractions, what do we have, adding or subtracting or comparing fractions? We have to have like denominators, but why? Why? Gabe?
So that everyone gets an equal piece.
Right, so that our whole has the same size pieces that make the whole. Otherwise, we can't work with those fractions because they're different sizes, right? The whole is different. The pieces that make up the whole are different sizes. Okay. Any other questions, comments for Allie with her strategy? All right, Michael, will you please come up and share your strategy? And tell us what you're doing as you do it.
Okay. So I did was I make the denominators equal. So I was 2, 4, 6, and then so I just like 2, 4, 6. So I did my 2, and then 3, 6, and I got my common denominator was the lowest. So I got 6. And then I went 1, 2, 3, and then I times it by 3. And then 1, 2. So then I got 3, 6, and 4, 6. And I just added it. And that's how I got my answer.
Any questions or comments for Michael? Sydney?
What's your visual representation?
Well, we don't, what is he using for his strategy here?
Algorithm.
An algorithm,
Which is
okay?
a model.
It is a model, right, right. Allie?
I would like to agree with your answer, but I don't understand how you went, like you counted up numbers and you just times it by that.
So Allie's asking, when you wrote the fraction 1/2 and then you went 2, 4, 6, what do the 2, 4, 6 represent? How'd you come up with those numbers? What do they mean?
I don't know. This is what my teacher taught me how to do this.
Okay, because Michael's new to our class, right? This is a new strategy. We haven't seen this strategy. It's really cool, but we need to make sure he understands why he's doing what he's doing, right? So Cinder, what do you believe that those numbers 2, 4, and 6 represent?
Just multiplying them by 2 and seeing what the factors are.
Not factors.
The sum.
Multiples, right. So this is a great strategy. I've never seen this one before. It's really cool. So we, last week I showed you how to list the multiples this way, right? And he listed the multiples right under the denominators, which is really a great strategy so that you can visually see for each fraction where that common denominator is coming from. And we always want the least common multiple. So he did, these are multiples of 2. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. And then over here, 3 times 1 is 3, 3 times 2 is 6. So, and this is really great too. So he just counted back up, 1, 2, 3. That means he multiplied 2 times 3 to get 6. So that's a great new strategy that Michael's able to share with us. So Michael, what do the numbers 2, 4, and 6 represent?
By timesing it.
Who can help Michael out? What are they? Drake?
The multiples of 2.
Okay, so they're the multiples of 2. So what do your numbers 2, 4, and 6 represent? Very good, good. Any other comments, questions for Michael? Yaneli?
I think it's also, I believe it also kind of looks like what Ali did because she's doing the same, but not like his strategy. She's just using shapes for it.
Right. So instead of, Allie didn't find the multiples, instead she used the visual model, right? Instead of finding the multiples. But 4, 6 plus 3, 6. 3, 6 plus 4, 6. Absolutely. Okay. All right, any other questions or comments? All right, please have a seat. Thank you, Michael. All right, so if your strategy didn't get you to the same place as what was shared, please make those revisions in your work. Okay, some of you tried fraction circles. Will circles work with this? I mean, it could, but it's really hard to get those into, to subdivide them further, right? So fraction circles probably won't work. How about groups of a whole with pictures? Like 3 flowers out of 4. No, that's not going to work either. So
That would be a sign of a ratio.
right, exactly. So ratio, working with those kind of, that modeling visual representation isn't going to work. Now, if you are revising, please revise. Try not to look at the board. Try to remember what the process was that you just went through, okay? Yes, Jacob.
I have another strategy that like it gets slightly more well, I'm not sure. I converted it into decimals and it got 14/25.
Very nice.
1 and 14/25.
Interesting. So Jacob used one more strategy. We're not going to show it on the board, but he converted his fractions into decimals and then added them as a decimal. And that absolutely works, because what do we know about fractions and decimals?
They're the same.
They're equal, right? They're equivalent. Good. Should have had you share that one, Jacob. All right, please share with your shoulder partner what strategy you chose. Either if it was your initial and it worked, share that one. If you revised it, which new strategy did you use and why did you choose that one? Okay, go. So on this one, okay, so our denominators initially were 2 and 3. So in this one where you have 2/3, you're going to use this denominator to then cut it the other direction that many times, so you have 2 equals 5. So this one is 3, so we're going to take the 2 and we're going to cut it this way into 3 equal sections. And then if you wanted to not use the drawings, you would just multiply 2 times 3 equals 6, so that could be your new common denominator. Class, class. Yes. Class, class, class.
Yes.
All right, so now I have some very exciting, how many of you like pizza? Oh yeah, we all love pizza, right? Most people love pizza. So, I have some exciting news to share with you. Lena Juniper Elementary School has earned a pizza party for reading the most minutes during a district-wide readathon. 4 different kinds of pizzas will be ordered. Cheese. How many of you like cheese? Yeah. Pepperoni. Our pepperoni fans. Meat. And dessert pizza. Yeah, everybody likes that dessert pizza. Okay, so they want the students to be able to have their choice in that pizza. Okay, so we have to decide, how is the school going to decide how many of each pizza to order so that each student will get 2 slices of their choice? So what I'd like you to do in your math notes right now is write down some strategies on how the school can figure that out. How is the school going to decide we have 4 different pizzas and every student gets to order 2 of what they want, and they can be different. So how are we going to figure out how many pizzas to order? So write down real quickly, what are some ideas on some strategies? Give you about 30 more seconds. You can put your hands down. I'm going to pull sticks for this one. No. Okay, please finish up what you're writing, and I'm going to pull sticks, and you're going to come up and you're going to share your strategy with us, okay? So what is your strategy, and why do you think that that's a good way to collect the data to find out how many pizzas our school needs to order, okay? So let's start off with red number 1. Who's that?
That's red number 1.
Jesse. Oh, Jesse?
Yeah, I wrote it down.
You what?
I wrote it.
Can you share it with us up on the board?
Do I just write it?
Yeah. Use probably not numbers, right? And we're going to put 4 or 5 up there, so don't take up the whole board. So just write down your strategy, and then you're going to tell us why you think that's a good strategy. Okay, so read us your strategy.
Okay. Everybody can order at the same time, so everybody can get the same amount.
Okay, questions or comments about that strategy? Gabe?
If everyone orders at the same time, if everyone ordered at the same time, there might not be enough teachers to take all the orders at the same time. It can go by kindergarten to 2nd grade and so on.
Any other questions or comments? Skylar?
My strategy was kind of like that, so I agree with yours.
Okay, why do you agree, besides the fact that it's like yours? Why did you choose that strategy?
So they can know what everybody wants.
Okay. Jesse, or Elijah?
I'm disagreeing with Gabe because I believe everyone can order at the same time if they maybe, like Jesse said, do it by grade, or if everyone at the same time can write on the paper what 2 pizzas they want and put them somewhere.
Okay, so let's think about this for a minute. What is this going to entail? If we do exactly as Jesse has written there, I want you all to think of the 2 pieces you want. You're not going to write anything. You're all going to order at once. When I say 3, everybody tell me what you want. Ready? 1, 2, 3. Uh-oh, what's the problem?
You don't understand what they're saying. Write down a piece of paper.
Okay, so let's talk about that. Okay, so write it on a piece of paper. That's what Elijah suggested, right? Okay, but I don't want you to do that. Let's just pretend. So we're all writing on a piece of paper. We all gather it all up. How many students do we have in our school?
Over 500.
Over 500. How many pieces of paper are we going to have?
Over 500.
Over 500. Do you think that's an efficient way? Okay, quiet. Let's think for a minute, because we want it to be efficient. Would that work? Yes. Would that work eventually?
Yeah.
Yes, but is it the most efficient? Because we need it to be efficient. Efficient means it's the quickest and best way for us to do something, right? To accomplish a task. All right, thank you, Jesse. Anyone have a different strategy that they would like to share? Oh, let's just see if I pull out your stick and you say same, then that just means you have the same strategy as Jesse, okay? Green number 2. Oh, and you said you had the same strategy, right? Okay. Blue number 1. You have a different strategy? Okay, perfect. Come on up here and share it with us. us what you're writing as you write it.
Okay, well, each grade could order, they can like tell the amount of pizzas for each one, and one person can call for the, like how many pizzas of what kind they want.
Okay, so go ahead and write that down. So Sydney said that each grade would then order the pizzas for their grade. So be thinking questions or comments for Sydney about this strategy. Sort of. Okay, so questions or comments for Sydney? That each grade would then decide how many of the pizzas. Allie?
I would like to agree and add on because you said that each grade can get like can order the pizzas and then they have those pizzas. And what I was going to add on is that if each grade gets 2 pizzas, since there's 4 pizzas, each 2 classes could, or each grade could get like 2 cheeses, 2 pepperonis, 2 meats, 2 dessert, and then depending on how much pizza each of the classes want.
Okay, so let's think about that. Allie says every class would get 2 pepperoni, 2 of each type. 2 cheese, 2 pepperoni, 2 meat, 2 dessert. So each class would get 6 pizzas. Each 2 classes. So 2 classes would share. So 2 classes would share. So basically 1 of each kind for each class.
Yeah.
Okay. Any questions or about that strategy or comments on that strategy? Yes.
I'd like to disagree to what Allie said because if there one for class wouldn't be enough. Pizzas usually contain sizes like 12 slices per box, and I'm not. Then only 12 kids would get 1 slice.
Yeah.
And what was the original? Look at that last question. Each student will get 2 slices, what?
Of their
choice. So if we just order whatever 1 of each pizza, can we ensure that every student is going to get 2 slices of their choice? Because like Jacob said, you might, how many of you wanted pepperoni? Raise your hand. 2, 4, 6, 8, 10. So 10 of you. The pizza that we will order has 8. So that means, sorry, 2 of you don't get pepperoni. Yeah, so that doesn't work, right? That strategy doesn't work. Thank you, Sydney. So I'm going to go ahead and we're going to move on, and I'm going to share with you the strategy that we're going to use since we didn't get there on our own, and I want us to get to the math task. The strategy that we're going to use to collect the data is each person in every class will be asked which pizzas they would like for their 2 slices. They can order a slice from 2 different kinds of pieces, but they can only, order 2 slices. We don't want any odor. So what you're going to do is you're going to go back to your groups, and in your team tasks, you have this. This is your data collection for your small group. So in your small group, you'll write down what number you are, 1, 2, 3, 4, 5. This is a tally table, so we're going to be collecting our data using what? Tallies, right? So how many in the group want cheese? How many want pepperoni? These are tallies. Then total the slices down here, okay? Then you're going to come down here, and as a group, 1 pizza is equal to 8 slices. So you're going to write down how many slices. Then you're going to turn it into a fraction, and then reduce it into its lowest terms, okay? And so this part I want you to work in your groups on, not individually. Last time I had you work by yourself, and then we shared as a group. This is a group task, okay? So you're all working together in a group. Talk about your strategies first, talk through it, make sure everyone in the group is participating and understands how we take our data, convert it into a fraction, and then reduce it into lowest terms, okay? Yes, Yaneli?
Could it be possible if one person gets the slice, they want the same thing?
Yes, you can order 2 pieces of pepperoni, absolutely. Or you can order a pepperoni and a dessert, okay? All right, when I say go, you say? Okay. Go.